To put this nominal effective APR, APY to work, we're going to look at some credit cards, all right? And this is an actual credit card percentage. The annual percentage rate, notice it's not the yield, the rate is 24%. However, credit cards companies go by the month. So if the annual rate is 24% for the year, what would each month be then? 2%. It also says that right here, but you could probably figure that out. 2% each month to get to the 24% APR, also known as the nominal rate. So we're going to suppose you made a $1,000 purchase, and then you're not making any payments, you're not buying anything else, and then we're assuming there's no additional fees. Usually I think there's a thing called a late fee on top of it. Like if you don't pay it, they charge you a fee for being late as well. It's your job. Notice it says write expressions, so that's not answers, for 1 month, 2 months, 6 months, 1 year. You know how Mr. Mac rolls. A lot of times I'll do number 2 first here because I like to have my expression, my blank expression first before I start using it. Then you're going to see how much there is 1 year without payment and then find the effective rate. So to find the effective rate, you're going to go how much interest you made over original, right? It's going to be a percentage. We did this yesterday as well. You're going to write expression then for the balance of the car for years instead of months. 1 through 4, you're going to roll through with your partner. Let's go. So let's check out what's up with these credit cards. Guys, this is kind of like a real thing that happens with credit cards, all right? So you can leverage credit cards for like good things. Like, for example, I get like 2 to 5% cash back on different things depending on my credit card, or free flights sometimes or something. But the reason they can offer those things is because some people aren't paying them off and they're paying all this interest. So let's see what happens when you don't pay off your interest. I'm going to jump to number 2 first. How much am I in debt for? How much money do we owe? $1,000. That's debt. We owe it. And each month, what percentage are they charging me interest? 2. So 2% interest. It shows up as 1.02 because the 100% is no change. So, and then this is going to happen each month. So as I go back up to number 1, 1 month is 1.01 just once. Okay, you can put 1 there, wouldn't make it. But, sorry, it should be 1.02. I was getting on that 1 thing. Okay, so for 2 months, 1.02 happens how many times? 2. For 6 months, I'm multiplying by 0.02 6 times, and for 1 year, I'm multiplying by 1.02 12 times. For a total of a nominal of 24% nominal, or APR. So I'm going to go down here now to number 3. For 1 year, if I slap my 12-monther into my calculator, 1,000, I'm multiplying by 1.02 12 times, once each month, and that ends up being 1268.24. Which means I earned, kind of earned, right? That much interest out of my $1,000, right? Which means 26.824%. So I have to pay an extra $268.24, right? I divide that by my original amount of $1,000, and that is this increase. Now, this percentage is not nominal. This percentage is, you guys remember the word? Effective. Or we can call it APY, the yield. The yield percentage, not the rate, okay? So this is the effective percentage. Who can explain to me why it's higher than our APR or a nominal? Why is this one more? Because it's 24% interest APR. Yeah.
Because like with the first one, you're like adding, or you're like just like doing like 1.02 over and over again. But with this one, like you're like increasing by like the amount when you do.
It's getting bigger and bigger, but obviously.
It's like when you, I don't know how to explain it.
Yeah, it's hard to articulate. So let me ask you a couple questions. So if I did 24% for 1 year, it's just 1 year times 24%, right? But we broke it down into months, 2% per month. So after 1 month, are we still at $1,000? No. So when we go to the second month, we're already at a number bigger than $1,000. So that effect, right? That's why it's going to be a little more. So let's write an expression for years. This one, there's 3 expressions that I could come up with that are pretty good. We'll start with my favorite. I like to start with my favorite usually. There's $1,000, and my rate for each month is 1.02, and I can do 12 times the number of years. 12 times the number of years would give me the number of months. And this is going to be a little throwback to the warm-up. Another way we can write the same thing is this. You might see this on like homeworks or something, is a little double parenthesis action. So right here, that 1.02 in the parentheses to the 12, how long is that? That's 1 year. So I'm going to raise my number of years to t years, and it would be the same thing. Just like, do you guys remember the warm-up, those two expressions that were the same?
Yeah.
Okay, Tyler and Kieran. Tyler, by the way, is not a common math friend. It's kind of nice to see Tyler once in a while, you know? And then the last one. The last one is the worst one, I think, but it still kind of says what's going on. The last one would be $1,000 times my effective rate, 1.26824. It's not exact though, right? There's some more decimals that I'm missing. That's why it's not exact. And so this would be the rate for how long? Effectively for how long?
For a year.
For 1 year, which means I can just raise that to the t power then. Because that is the 1 year. If I took this part, 1.02 to the 12th, that is that part. All right? My personal favorite's just right here. It's all there. Right? You can't, there's no more simplifying. You just plug in the number of years and go. And in fact, if you told me how many years, I'd probably just write the number of months. I don't even mess with 12 times. I'd probably just write the number of months there. So, credit card interest, no joke, right? If you don't touch it for a year, $268. If you can't pay off $1,000, how likely are you to be able to pay off that extra later? Probably not super likely. So, ten cuidado. Let's take a look at this. Now you get to make money. I'm about to go broke. I'm giving you all $500. Okay, you all got $500. You have two options for your $500. You can either invest it, option 1, which compounds every 3 months. You get 3% interest. Or option 2, every 4 months you get 4% interest. It's $5 either way. What's the nominal interest either way? Or the APR? Nominal. How much is it either way? I got 3% that happens 4 times or 4% that happens 3 times? 12. Either way, my nominal's 12. It's your job to decide which one of these is better. Or maybe is either one better. I don't know. They have the same nominal. It's your job to see. Let's go. So one thing that several of you noticed is this doesn't really give you a time frame. I'm going to choose just to look at 1 year, and then we can talk about a couple things. So looking at 1 year for option 1, we have $500. It's going up by what percentage? 3%. And if it happens every 3 months, how many times would that happen in 1 year? 4 times. Okay. So that means my $500 is going to turn into $562.75. Okay, option 2. Option 2. I have $500. It's increasing by what percent? 4%. And if that happens every 4 months, how many times would that happen in a year? 3. So we're just comparing 1 year to 1 year. So if I do 500 times this higher percent 3 times, I get 562.43. Ooh. So you want to get rich and rich, make 32 extra cents. Option 1. That's if we look at 1 year. Oh, let's test it out. Sam thinks past 1 year, option 2 is more. How many years do you want to do, Sam? 10 years? Let's do 10 years. Let's try it out. So, option 1, for 10 years, 4 times a year, that's going to happen 40 times, right? Option 2, for 10 years, that's going to happen 30 times. Let's see what's up.
Option 3 is always going to be more. It's always going to be more.
Let's see. No, we're going to see. Oh, the gap got bigger. So here's why. So obviously, if we have the same nominal percentage, if one has more opportunity to compound, right? This one gets to get compounded 4 times, even though they have the same nominal. It looks like the more times it gets to feed itself, in between, what ends up happening to the effective rate? It goes up, right? The more times you... So if you wanted an even better one, even if it's 12% nominal, if you could get a compound every month, Even more. Let's test it out.
Well, isn't
Yeah.
option one going up every month by 1%?
No, option 1 is going up 3% every 3 months. So 4 times a year it compounds. Option 2 is every 4 months, which means that one only happens 3 times a year. Now the one time I would say option 2 actually is if you were only going to keep your money for 4 months or 3 months, that would be option 1. But if you were going to keep your money for 4 months, would option 1 happen another time? No. So if you're only going to keep your money for 4 months, pick option 2. You guys seeing that?
Yeah.
Because the option 1 wouldn't get to happen a second time. You'd have a percent better. Okay? So again, the more times it can feed itself, same nominal rate. The more times we can feed itself with compounding, the higher it's going to be. Now, I know like 32 cents isn't like huge. So like maybe you're just like one investment guy more than another. So you pick that one. But so again, that's the big idea. The more times to compound, same nominal rate, the better. All right? So next up, this is kind of related, but more like a practice using negative exponents. We're going to roll through number 2 together. Number 1, this is actually a pretty solid price of college. I compared it to my college experience for tuition. This is tuition only. This would not include like housing, food, books. Here's our function located up here. It's your job to look at the function and say, what was the cost of tuition in 2017? What is the percent growth? You're going to tell me how much college cost in 2000 and 2010. And then what tuition will be with this model for when you graduate. As on the board, mouths closed, friends. Who can give me how much tuition was in 2017? Greta. $15,000. Seems like a lot to me. What's the rate at which this tuition is changing every year? Yeah, 7%. And I'll let you know, that's a good average. When I was in college, when they would give us our new tuition for the next year, now some of it's based on credits and stuff, but sometimes it was like a 9 or 10% increase. But sometimes it was more like a 6, so it's about 7. I think this is good. So we're going to go 10 years before 2017. The year 2000, I was a freshman in high school. And as I was going around looking at answers, I could not glean as much as I wanted from the answer as I could if you wrote an expression. So let's check out the expression. I've got $15,000. It's going up 7% a year for negative 17 years. I'm going back in time. We're time travelers. So 1.07 to the negative 17 gave me somewhere around $4,748.62. Okay, so that would be 17 years ago in the year 2000. So just 10 years after this, in 2010, how many years before 2017 is that?
7.
Yeah, so I got negative 7 for exponent there.
And that's like 9,300.
And that is like, yeah, $9,341.25. Just 10 years after that. So it almost doubled in 10 years, right? You guys seeing that? And I would say I graduated college. You know, I'm super youngish. 2009. And that's pretty close to what... I went to the cheapest college, state university, Saginaw Valley State University. I should rephrase that. The least expensive. And my senior year was in that ballpark for tuition. But you got to remember, when you go to college, again, you're going to have like housing, which if you live on campus is like double, makes it double. Half of your price can be housing. So I would say these numbers, like, they kind of check out for my state university I went to. What will it be when you graduate? So you guys hope to graduate how many years after 2017? So 10. You guys got lucky. You got a nice one. 10 years after? So 15 times 1.07. 10 years after 2017. $29,507.27. Guys, that's just to go to class. That doesn't count books and stuff. So start saving. I'm going to tell you right now, this is extra. Ask your parents about a Michigan 529. It's an account for education where they will not penalize you for taxes when you pull it out, and you can put it in investments and hopefully grow it more than other things. All right, let's look at number 2. They want you to do some crazy like division stuff. Watch how nice this is going to be. We're going to speed run number 2 together. You ready? So 2017 to 2027, how many years was that? 10 years. So we did 1.07 how many times? 10 times. That's the factor at which it grew. 1.07 to the 10th. Let's pick another 10-year period. How many times are we going to multiply by 1.07 for that one? No, for any other 10-year period.
Oh, 2037.
It's just 10. It doesn't matter what 10, like 2027 to 2037, that's 10 more times.
Oh.
So what we want to say is no matter what your 10-year period is, your factor that you're going to multiply by, 1.07 to the 10 more.
Oh.
Now, this looks the same, but is the price going up the same amount each time? No, because this is a factor, right? If it's doubling every 10 years, about doubling, right? That gap's going to be bigger and bigger. That's that rate of change, right? This is a factor. This is what you're multiplying by, which is making it almost double every 10 years. So take a gap year, it costs you more, actually. But maybe your life experience will be worth it all. Okay? So we're going to do this this together. We're going to go back to our assigned seats with our lesson summary first. Bottom two. So the first one is annual. We've seen this a bunch. One time, 6%. I would take my $1,000 and I'd multiply by 1.06 one time. This is 1 year. 6% a year, 1 year is 1,000 times 1.06. That's like that. We've done that for a couple days now. Semi-annually, every 6 months, how many times is our money going to compound? 6 months happens how many times in a year? 2 times in a year. Which means the nominal interest rate for each segment is going to be 3%. So we are going to multiply 1,000 by 3 2 times. This is still 6% nominal. We're just doing it 2 times. What is this going to do to the effective rate? The more times we compound, what happens? Goes up or down? Up. Because it's building into itself earlier, more times, right? So we're going to go quarterly. How many times is it going to build in a year if we go quarterly? 4. I'm going to take my 6% and split it up among the 4 quarters. They're each 1.5%. Because 6% split among 4 different quarters is 1.5 each quarter. 1.5, 1.5, 1.5, 1.5, 6. So my $1,000, I'm going to increase by only 1.5%. But how many times we're going to do it? 4 times for 1 year. And this is going to give me a higher effective again, a higher effective rate.
Is that 1.0?
Yeah, a 1.5% increase. And monthly, how many times are we going to do it for monthly? 12 times. And I'm going to get 0.5% interest each month then, right? 1/2 times 12 is 6. My $1,000 then, I'm only going to increase it by 1.005 each month. But how many times do I get to do that? 12. And as we go up, that's going to have, on this table here, the highest effective rate. It gets to build into itself the most, right? The more times you get to compound, the higher outcome. There's one more I want to write down here. I don't care if you write down or not, but maybe you should because it'll help you on your homework. I want to look at daily for a year. So if you were to do it daily, how many times will it happen in a year? 365. And to get your percentage, okay, you need to split your 24% up. You're going to do 24 divided by 365. Well, no, don't. It gives you an ugly decimal, so that's why I'm showing you this. So to write this expression, so you don't have to use this long ugly decimal that won't be perfect, you would write this. To get percentage to decimal, we go 0.2. Sorry, it's not 24. I did this before too. We're at 6%. I went back to the credit cards. Okay, sorry, you should not listen to that 24. We're at 6%. So 6 divided by 365. To go to decimal, it's going to be this. So this is the decimal for the 6% split up. 1 plus this will give me the 1 point whatever jump. This is 1 plus 1.5%, right? The reason you'd want to put in your calculator like this is it'll keep all your decimals kind of in place. And then we would raise that to the 365. There's a question like this on your homework. It's not different. I know it looks different. It's just when we do that division by 365, we get such a brutally bad decimal, it's almost unusable. Okay? Homework's in the basket. To the